Hey everybody, hope you're having a great day today. Today we're going to work on the volumes of similar solids. This is the third part of 8.4. So we did identifying similar solids, finding missing measurements that way. Then we did surface areas of similar solids, and where we had to square the ratio of the one-dimensional measurements and put it equal to the surface area ratio. Here with volume, since volume is a three-dimensional measurement, what we're going to do is we're going to make a ratio of the one-dimensional measurements. Like for instance here, we have the radius of A over the radius of B. We're going to cube that and then put it equal to the volume of A over the volume of B. So we can use this ratio to find missing volumes, to find missing radiuses or heights or anything like that, as long as we just set up our ratios correctly. So let's give it a try. So here it says dimensions of the tank at an aquarium are doubled. What is the volume of the new touch tank? So when you are doubling something that has a volume, what's happening is you're multiplying it by 2, right? Each one of these things you're multiplying by 2. So if you multiply each dimension by 2, you're actually making the volume 2 to the third times bigger. So you're making the volume 8 times bigger. So if the original volume was 2,000, 8 times bigger than that would be 16,000. So for this answer, it would be 16,000. So whatever you're multiplying each dimension by, you're going to cube that multiple, and then whatever that is, that's how many times bigger the volume is going to get. All right. So here it says the solids are similar. Find the volume of the red solid. Round your answer to the nearest tenth. So. Alright, so we know that they're given the heights of the red and the blue. So if I make a ratio of red to blue, it would be 5 over 12 in terms of the linear measures. And then I'm going to put it equal to the ratio of the volumes. Now, I don't know the volume of red, so I'm going to put it as x because 5 is on top. And the volume of blue is 288. Now if I want these to be equal to each other, since this is a one-dimensional measurement, this is a three-dimensional measurement, I want to cube one-dimensional measurement. So 5 over 12 cubed is 125. And 12 cubed does elude me. So 12 to the third power is 1,728. And then I put that equal to x over 288. Now I'm going to cross multiply. So 1728x equals 125 times 288, which is 36,000. Oops. 1728x is equal to 36,000. And then do 36,000 divided by 1728. And I get 20.8. So x equals 20.8 centimeters. It was 20.83, but I believe it says round to the nearest tenth, right? Yes, it does. So 20.8 centimeters cubed is the volume of the red figure. All right, so now here, I know that the side length of one of the bases of this pyramid is 3. And this one it's 4. So 3/4 of the ratio. Remember, you always see if you can simplify it. 3/4 cannot be simplified, so I'm going to leave it like that. But that's going to be equal to 9 over x. So that gives me 27 over 64 equals 9 over x. So 27x equals 9 times 64, which is 576. So I cross multiplied there. And then I divide 576 divided by 27. And I get 21.3.
It's off now. It's off.
Little Pete's yelling in the background. So that's 21.3 inches cubed. All right, so that's how you find the volume of missing shapes. So you take the ratio of the side lengths, and then you cube them and put them equal to the ratio of the volumes. So why don't you guys try out the BIM. If you have any questions, attend an open meet or send me an email. Pete, come say goodbye. Come here.
Goodbye.
Say goodbye.
Say goodbye.
You gotta say goodbye to the computer.
Goodbye.